Energy and reactions. For an event to occur, such as a solid to melt, an atom to ionize, a liquid to vaporize, or a chemical reaction to take place, depends on the particles involved having sufficient energy to carry out this event. The energy of particles at Kelvin temperature T is, on average, kT, where K is the Boltzmann constant, with the value of 1.38 times 10 to the minus 23 joules per Kelvin. This is the average temperature of the particles. Some will have much more energy, and some much less. We find that if the average temperature kT of the particles is around the energy epsilon needed for the event to occur, it will be over almost instantaneously. If the energy needed for the event to occur is around 10 to 30 times the average particle energy, the event will still occur at quite a reasonable rate, over the space of a few seconds probably. If the energy needed for the event to occur is around 100 or more times the average particle energy, the event will hardly occur at all. So just to summarize, if the energy needed for a reaction to occur is around about kT, the average energy of the particles, most of the particles will be able to carry out the event immediately, and so the event itself is almost instantaneous. If the energy needed is between about 10 and 30 times the energy of the particles, then the event will take place quite quickly, over the space of a few seconds. However, if the energy needed is more than around 100 times the average energy of the particles, then the event hardly occurs at all. This tells us that a significant number of particles must have around 20 times the average energy, and that hardly any particles have over 100 times the average energy. For example, the energy needed to vaporize one water molecule is around 6.8 times 10 to the minus 20 joules. On a warm day, we have a temperature of around about 27 degrees Celsius or 300 Kelvin. So we can write that the energy needed is 6.8 times 10 to the minus 20 joules, and the mean energy of the particles, kT, is 4.14 times 10 to the minus 21 joules. So energy over kT gives us a value of 16. This is between the magical values of 10 and 30, meaning the puddle will evaporate quite quickly. However, if water is dropped onto a red-hot metal at around 1000 Kelvin, then the energy to vaporize the water will be the same, but kT is now much higher. So energy over kT gives a value of 5, and in this case the vaporizing is almost instantaneous.